Oh, good morning, class. Welcome to a top secret location in downtown Morganton, North Carolina. I'm just trying to film a little bit of what I'm doing here so we can use this in class. And at the very least, you can lay your eyes on some practical aspects of the work we're doing. This is the same place that I was working in the other video where we rewired the light switches and all that kind of happy stuff. We're also upgrading the service on this home to a 200 amp service. What we're looking at currently, there's the point of attachment where the city brings the power in, and from that point, and this little object lesson, from that point where those connections are made down through this service riser, from that point where those connections are made down, that's customer wiring. From those connections back, that's utility wiring, so we don't mess with that. But what we're going to be doing here is upgrading the service. What you're looking at is a 100 amp, 120, 240 volt single phase residential service. The lugs in the top of that meter base are hot. There's 120 volts on each leg, and then below here, everything from there on into the house is dead, as I have removed the meter. Okay, by removing the meter, we turn off all the power to the house except at this point right here. So what are we about to do? We're going to upgrade this to a 200 amp service. Now you're looking at that panel, it's sitting there upside down. As you can see, the top of it, which is on the ground, is where the meter will go. There's your 200 amp breaker, your breaker spaces, and all that kind of happy good stuff. And so we're going to replace this. There is a 100 amp indoor panel in the wall inside there. This wiring is what feeds that. Now this happens to be in PVC conduit the entire way, which is as lucky as it gets when you're upgrading the service. Normally that's just going to be cable, and you're going to have to replace the entire length of that cable with a 4-conductor cable. As you notice, there are 1, 2, 3 conductors coming out of the bottom of that meter, 1, 2, 3, and feeding into the panel inside the house. Okay, so what we have here is 120, 240 single phase service. 3 wires are feeding the panel. Now that panel is 20 feet plus feet away. This wiring would never pass current code. However, it meets the code for the time in which it was installed. But we are going to install an exterior 200 amp main breaker panel. We are going to leave that wiring in place, and we're going to sub feed it from a 100 amp breaker in this panel. I may use a 60, I'll calculate the load, but we will sub feed it from a breaker in this panel to that panel inside. And the panel that currently is the only panel in the house, the one inside, will become what's known as a sub panel. It will be sub fed from the main panel, which will be this. Okay, and this is a meter panel outdoor combo, a NEMA type 3R enclosure that's rainproof and weatherproof. Now, a couple modifications we'll have to make. What am I about to do? Well, the meter base up, that's going to stay in place, although I am going to disconnect it and swing it over here somewhere out of the way and tie it up out of the way, because we will have to use it to temporarily feed into this panel to keep power on in the house until we get an inspection, at which point, once the inspection is passed by the Morganton City Electrical Inspector, then the city will come out, they'll cut this loose and lay this on the ground, and they'll connect up the new riser that we're going to put up out of this panel and hook it all up. But until then, we have to temporary it to keep it hot. Now, fortunately, there's no one living in this house at the time. The owner's doing some work to it before he rents it out, so it's not a big deal, but there is a refrigerator in there and all that we do want to, we want to keep it running. We don't want to sit there idle. So before I leave, power will be back on, albeit temporarily. So what am I going to do? I'm going to remove this, and this thing here is called an LB. I'm gonna have to remove it. I'm most likely gonna have to saw this right here so I can get the meter base out of the way. Then this is glued on here and it's gonna be rich, but I'm gonna have to somehow get this LB off and put a connector on it. And this wire will come straight out. There'll be a connector. That connector will go here, and then we'll feed that wire up into that panel and put it under a breaker to serve the house. Now, one thing I am gonna have to do, we'll talk about this in class, but the 3-wire feeder from the meter to the panel is for the main panel only. Anytime you feed a panel from another panel, anytime you sub-feed a panel, and you know, it's called a sub-panel, you must feed that panel not with 3 wires, not with 2 hots and a neutral, but you must feed that panel with 4 wires. You've got to feed it with the 2 hot legs, the neutral, and a separate equipment grounding conductor that you have to run to that panel. And in that panel, you have to separate your equipment grounds, which typically in residential wiring is going to be in Romex, and so that's the naked bare ground wire in that cable. They have to all be placed on an equipment grounding bar, and there will be a green conductor that will feed from this panel in there. I will have to add that. Now, like I said, I'm fortunate. This is in conduit the whole way. I'll just pull that additional conductor into that conduit, and let's hope we don't have too much trouble out of it. But that's what we'll do, and we'll hook that up at both ends. So that's just a synopsis of what we're going to have to do. We're also going to have to add an additional ground rod. The code specifies more than 1 ground if the resistance is over a certain ohms value, but I can go ahead and tell you, if you don't drive 2, the inspector will fail it. That's just sort of kind of become common practice because inspectors don't typically check it, and it's basically become common practice. Now, there is a ground rod here already. I will have to add a supplemental ground rod probably that way, since there's a bush in the way over here. It has to be a minimum of 6 feet from that rod, and all 3 rods have to be, or both rods, excuse me, have to be tied back into the main panel here, and that connection has to be made up here in this. Actually, this one may allow for somewhere else. It just depends. Sometimes we might can make it down here. Electrically, it doesn't matter, but you have to pay attention to what the manufacturer's sticker says, because if you hook it up in the wrong place, the inspector will turn it down. So at any rate, this is coming down, that's going up. We're going to add a equipment grounding conductor from here to that other panel, so we have a 4-wire feed to that panel. We'll set a breaker here to serve that panel. So just wanted to give you a quick rundown of what I'm doing. I'd like to give you a little bit of, this gives you at least a view of some electrical work that's actually going on in the field. And obviously I can't film this while I'm doing it because it's just me, myself, and I don't have a helper. And so I got to do this all myself, and it will require both my hands. So I'll come back at a certain point and let you see what we've done, and we'll pick it back up. All right, bye. All right, class, I'm gonna try and bring you back at intervals here so you can see where we are. As you can see, remove the LB. The only way to get this joker off was to bust it off, basically. We're very fortunate again. Actually, that slipped right out of the coupling inside, so I should be able to make this work without too much issue. You might have to add a little pipe, but that's okay. You can see where the old panel was and how they trimmed around it. The old wood siding behind it. We'll take these pieces off so our panel will sit flush, but it will completely cover that. It'll look much better once this is up here. And this is over, swung off to the side, being supported by that, and being supported by these wires here that I have temporaried up to just simply hold it in place. Once this is up and all the wiring is complete, there will be a temporary wire coming out of the bottom here over into this panel to feed it temporarily to keep power on inside the house until the inspector approves the work. So that's where we are. Just wanted to show you what we've done. I stuck the meter back in and put the cover on it just to cover up the live parts so it's safer to work around. And that's where we are. All right. All right, here we are, not too much later. And as you can see, we've got the new panel meter combo mounted solidly to the wall. and we used a connector, and we attached the feeder wires and conduit coming in the back. This is knocked out. I knocked that out by accident. I wasn't paying enough attention. If that happens, I'll have to put a knockout cover, a plug-in blank there. Not a big deal. We'll do that. I got to add that third wire, or fourth wire, excuse me. But normally I'd go ahead and do my riser, which I've got to run a new riser up in 2-inch conduit, which I will do. But there's a tropical storm coming, and it's been creeping along, and I didn't realize it. I got to check my weather radar. But I'm going to go ahead and get this temporary around here so that in the event it takes to raining like crazy, I can go ahead and get the power back onto this house so it won't be out of power, and that much will be done. So anyway, just wanted to show you what we have left to do. We got to get our riser up, get that connected in the top. We got to get our ground wire, grounding electrode conductor, that'll be the bare copper, to that ground rod, and drive a new one, tie them all together. We've got to pull a fourth grounding conductor into that conduit to the inside panel. All right.